Hey everyone, it's your boy Mr. Summers back here for another sweet evolution lecture. Tea time! Just gonna grab some tea, sip it. And let's talk about patterns of evolution. Can't wait, so excited. Ooh, I'm gonna keep doing that. Just get my face up in this. Hey everybody. Just want to say a shout out, quick one to my P4 class. Me and Mr. Schmickley miss you so much. We talk and text about it every day. Both of us cry. Yeah, let's do this. First of our patterns of evolution happens to be one that is called adaptive radiation or divergent evolution, which is the idea that things can start as one species. This circle that, yeah, technology, and then radiate out into a bunch of different ones. Look at this. It's like art majoring, right? All of that can happen because whatever it might be in their environment would cause one initial species to become a bunch of different ones. That could be the fact that maybe this one has to eat fruit, so it's got a different beak, or these ones eat insects, so their beak is more pointed to be able to fish them out of stuff. Seed eaters have a bigger beak to be able to then eat stuff like that. So in this case, in this adaptive radiation, the thing that was causing the differences was the fact that there was different food available. So that is adaptive radiation. Again, one single species diverges to become a bunch of different species. Second one, ooh, I'll move my face. Hey, I'm up here, everybody. Second one is that coevolution is two species evolving in response to each other. So my class watched this newts and garter snakes video, or if you watch the hummingbird video, those are two species that are co-evolving. In this case, the toxic newts were evolving higher levels of toxicity, and the garter snakes were evolving the ability to sustain an interaction with a newt who has a high toxicity, to then be able to survive and eat it. Right? That's two things. It doesn't have to be predator prey related. It could be the hummingbirds were evolving beaks that were bigger, so that they could get deeper into the flowers to get more stuff. In the case of bees, some bees evolve stickier legs so that they can go away, Anna. Sorry, my daughter keeps wanting to build a snowman, so I have to tell her to go away. Bees evolved stickier legs so they can carry more pollen, pollinate more flowers, right? That's co-evolution. Co, in this case, meaning together. Ooh, look at that arrow. I'm so good at technology. And then if two species try to be in the same niche or role in their environment, they can evolve to look similar because that's what's best for their environment. So things that are not even closely related, this, which is a dolphin, and this thing over here, which is a great white shark, I'm just going to call it great white, I literally have no clue what that is, evolved similar appearances. This is a mammal. This is a cartilaginous fish. They are not anywhere close to each other, right? But their role in their environment is the same, so they evolved similar appearances because of that same concept. So obviously things that swim evolve, some sort of flippers and fins, right? Because that's what works to swim. Convergent evolution. So good at stuff. Selective pressures are things that are changing an environment. So how it works, if you look at these graphs, if you can't read, I'll read it for you. The selective pressure happens to be the blue arrows. This is the original population. This is like pertinent. This is flattening the curve right here, team. And then the new evolved version of that. So if this was the normal distribution of, I don't know, colors of whatever it might be, starfish, right? And there were light starfish on one end and dark starfishes on the other ends. And being the middle starfish was the best starfish possibility, right? That's what this curve is showing you. The first happens to be stabilizing. So, like I said, right? Where'd my sweet pointer go? He gone. Oh, cool. Stabilizing selection is pretty simple, right? In this case, the stabilizing selection this and this, the two extremes, are least fit for their environment. So the middle ground is where the population will evolve to. It'll move me up there. If, let's say, something happened, right, and being the dark colored starfish meant you could blend in with your background more, the population would start to evolve to look darker. That's called directional selection. And let's say being the middle one was the worst, right, where light or dark starfishes had a better chance at survival, and the middle starfish was the one that had no chance at survival, the population started to change towards those two things. It's almost starting up a speciation process or a divergent evolution there where the middle ground is the worst. Speaking of speciation, if you want to watch it, feel free to click on that thing. To become a species, to be an actual species in nature and in science, you have to do not just breeding, but you have to be able to breed and make fertile offspring, which if you watch Tiger King, because it's hot with the kids these days on the Netflix. Have you heard of Netflix? Tea time? Hey, kid in college, put your phone away. Right? So if you understand that concept of like, if you watch Tiger King, that one guy, Bhagavan or whatever his name is the one that breeds ligers, which are half lion, half tiger, right? And that, I'm just gonna put that there for you guys. That is two species that can breed but cannot produce fertile offspring. So ligers in this case are not fertile. They can't make more ligers. I always get this backwards. I'm going to say it on the camera, so I feel like I'm really bad. But I feel like it's like a horse and a donkey makes a mule, and that's what I'm going with. You can't make more mules from mules. They can only be from a horse or a donkey. That's, again, two different species. Horses and donkeys make mules. For speciation to happen, you have to be able to then be separate and isolated from each other. I'll put myself over here. Yay! I look so good. You can do that reproductively, or you can do that because you can't physically get to each other. So again, to be species, you need those two gene pools, population to become separated from each other. There are a bunch of different versions of how that can happen. Maybe mating calls don't pan out anymore, different breeding seasons, or it could be something as simple as like, there's a mountain range in between the two. That is tough for squirrels to breed on one side of a mountain range with the squirrels on the other side of the mountain range. There's mountains in between them. Oh, hey, I'm somewhere over here. So 3 types of reproductive isolation. Behavioral, exactly as it sounds, some sort of behavior process. Maybe things are incapable of breeding because they don't have the same type of courtship. Maybe if you were watching Rio every day, like Team Summers is, and the blue macaw does that little dance to like mate, but then the other weird birds don't do that one, then obviously they're not gonna be able to mate together because their behavior differences are too extreme. Oh, look. If you want to click on these, you can watch those east and west meadowlarks. You can have geographic isolation, which can be an actual physical barrier. Right? Oh, hey, I'm back. East, west. I circled them. Click on those when you're bored, in the actual presentation. Again, geographic isolation can have a physical barrier. There has to be something separating the two regions. Obviously, my dog, if you saw him in the last video, cannot breed with dogs in, Mexico. He's here, Mexico's far away, he's not getting down there. Even if I sent Jeeves with a private jet on the G6 down there, he ain't gonna get it. And then, ooh, look, I showed you some more stuff. Oh, yeah, things. And then, if it happens to be at different seasons, so a fish, rainbow trout and brown trout are actually in the same stream. You can fish for them if you're rich, me, and you go fishing all the time in fancy places. Even though they're in the same stream, they don't spawn at the same time. Even like this last summer, I fished salmon in Alaska, and then we fished king salmon and sockeye salmon, and then like 1 week after them, the the silver salmon came up the river to spawn, so they physically didn't spawn the same time. So you can have differences between this brown trout, look at him, and this rainbow trout, all because of the time in which they breed, right? That's temporal isolation, right? If it's fall and spring, then you're not going to have species that evolve together. Hey, look at that. Blank screen. I'm done. I'm going to move me down to the middle because I'm the most important part. And go big. Go big. Hi. Do your work. All your teachers miss you. We'll see you soon. I didn't hit the button to end this, so it's got awkward. Tea time! Hey, Schmickley. You done?